Hey everybody, this is Sam from Campbell Scientific. We're just doing a little backyard experiment, backyard look at the Hughes9502. Specifically, just wanted to show the power-up sequence and some current draw numbers. Battery voltage is about 12.9 right now, but you can see I just powered it up. We got the power light, then all three lights, then the first two lights, and then the unit will start to go to flash the power light. Then we'll see it flashing the GPS light, and then it'll move on to the satellite link light. There we go, it's going to the GPS light. Sitting there drawing about 0.3 amps, 0.2 amps now. So it goes through these various states as the terminal. This is the terminal here at the top. The terminal gets a fix as it's trying to get a narrow beam fix on the Inmarsat BGAN network. And with a narrow fix, the Hughes9502 provides us an internet connection, internet access. So it's got a narrow fix now. You can see all the lights are on. Here in a little bit, it'll actually time out and go to a regional fix, which is a lower power state. You can get the Hughes9502 package, the full package from Campbell Scientific. We've got everything you need to install it and get it connected to your data logger. Got really nice mounting brackets for the terminal itself. So this is the terminal. Real nice mounting bracket for being able to mount the terminal flat or on edge. Also, the package comes with the antenna and the antenna cable and an antenna mounting bracket. You can see the antenna here in the background. Real nice antenna mounting bracket. So you can see the lights just went off on the terminal here, and soon the terminal will go into a lower power state as it gets a regional beam fix. So the kit also comes with all the cables you need to power the 9502, or to connect it up to a like a PS100 or a PS150 or a PS200, something like that. It also comes with all the cables you need to connect it to an NL device, an Ethernet cable. It comes with a DB9 cable that you can use to control, do a hardware control of the power state of the 9502. So there you go. We dropped into a little bit lower power state there, 0.07 amps. Okay, so it's sitting there on a regional fix. So this device, you can connect it to a CR1000 or CR3000 with, say, like an NL116 or NL121. Or you can connect it to any of our data loggers with an NL201. So, basically we need an Ethernet interface here. Of course, the CR6 has got the Ethernet port built right in. All of them have the ability to talk to the 9502, use it to access the internet, do things like connecting back to a LoggerNet server or a PACBus router for doing PACBus TCP. Most of our loggers have the ability of sending data via email or FTP, being queried with DMP3 or Modbus TCP. So a wide variety of ways to get your data from your data logger over the internet. So I'm just going to take a quick look. Obviously, this is just out on my back porch, so it's not really pulled together. Just doing a little backyard experiment. Here, I've got my multimeter in line to measure the current draw straight from this PS100. Of course, now we sell the PS150, which is actually much more suitable for this application because it can supply the higher current draws needed when this device is transmitting. I've also got the CR1000 with the NL116. I've got this cable here that goes to the GNSS port on the Hughes, and by toggling pin 9 on the Hughes, we can actually force the unit into a low power sleep state. If you set port 9 high, it puts the Hughes into a deep sleep, takes it off the network, but it's a real convenient way instead of having to try to control the system power with, a relay or something like that. So there's your antenna cable, and it goes over to your antenna mounting bracket. Of course, this would be connected to a mast on your station. So we're just going to take a look at a little demo, I guess, I got set up here. I'm just got my Sierra-1000 running a simple program here. We're taking a look at the power draw, and what I'm going to do is I'm just going to tell my data logger to FTP some data. So as soon as I started that, the data logger attempted to communicate with the internet. It caused the 9502 to attempt to get a narrow beam fix, and we can see that it didn't get it right away. It takes a little bit, it takes a few seconds for it to get the fix. Oh, but there we go. The FTP data went to 0, and our FTP result was -1, which means success. We transferred our data. So we'll go and take a look at our FTP site. Let me just refresh this. Oh, and there we see our file showed up. About a 2 kilobyte file there that contains our CSV data. Okay. So it's going to stay in this narrow beam fix until a timeout. You can actually control this with a setting in the 9502. There's actually a wake on LAN setting, and a setting that tells you how long it should wait, before it's considered idle. Right now I have the wake on LAN turned off, so it just sits there all the time, either in this regional beam or narrow beam fix. This unit, I've got all my services through Galaxy One. Galaxy One's been great to work with. I actually, have their logo here on the top. And they provide us the monthly services, data services for this, with some different, they have a variety of plans. You can actually get a static IP address for this unit, a public static IP address. So instead of pushing data, with PAC-bus TCP callbacks or FTP or email, you can actually have something like LoggerNet or a DMP3 master or Modbus client actually connect into your station, initiate the communications remotely. So right now I just have a private IP, so I'm doing everything initiated by the data logger. The data logger's initiating the connection back to the internet, back to the servers, and pushing data. So there, you can see it just dropped down to a lower power state. We can get this even lower by actually toggling that pin 9 on the GNSS port that I was told you about. So I have this little flag. All it will do is it'll set control port 8 on my data logger high, which is connected to pin 9 on that DB9. And when I set that high, you'll see the unit just goes into this deep sleep. It's not 0. I'm sitting here monitoring on a 20 amp scale, but it's pretty low. So it's a pretty convenient way to put it to sleep. It does take a while. When you come out of this state, it's rebooting. It's coming from a cold boot state. So you can see if I take this back to take that pin 9 back low, it starts the boot process all the way over again. So it takes probably 2 minutes or so, depending on your signal strength and how well you have the antenna placed and everything. But it goes through the whole cycle that we just viewed at the beginning of the video. It's going to start blinking the power light, then it'll start blinking the location, and then the satellite. And once this has a fix again, we can push data again. So you wouldn't want to use this pin 9, this deep sleep mode, for a station that needs very responsive, like event reporting time, like I've detected a flood event and I need to turn it on and tell somebody right away. It's going to take a few minutes, 2 minutes probably about to come up. So there's our time. We're still not on yet, but it's great for environmental monitoring. You turn it on and you report your data once an hour, something like that. Or this is a backup, for a event reporting network. You keep it in the deep sleep until you need it, then you turn it on and leave it on, and just keep it on the network, and it's real snappy, real responsive. So it's on the network now. There's our timestamp, and we can do our FTP again. So I'll just toggle that. I'm just manually doing this. Obviously, out in the field, this would be under program control. So it's just trying to get that that internet context, and we'll see. Yep. Okay. FTP data went to 0, and our FTP result is still -1, which means it was successful. I probably should have reset that. Another way of saving power is to actually turn the NL device off, so the data logger can use the IP net power instruction to put the NL device into a low power mode. So you can see I toggled that, and our network lights are off. So we're just saving ourselves about anywhere between 20 and 60 milliamps at 12.5, 13 volts when we do that, depending on the device you're using. So I can just toggle that back on, and immediately the data logger's Ethernet lights start coming back on. It does its negotiation, any negotiations it needs to do with the Hughes9502 to get back on. The Hughes is still up, still on the network. It hasn't dropped off yet. So I'm just going to see what happens here. I'm going to FTP this again, see what kind of responsiveness we get. It jumps up a little bit. Get both of those in there, and it's done. So you saw it jump up there quick, 500 mils or whatever, within the responsiveness and resolution of my multimeter here. All right, that's it.